Let's do a problem from your lab assignment, section 11.10. Here they want us to use the Maclaurin series in the table to obtain a Maclaurin series for a new function. And the new function is 13x times cosine 1/15 x squared. So it looks like we're interested in the cosine function, and here is the Maclaurin series from that table. And so our cosine is equal to you got n going from 0 to infinity, -1 to the n, alternating series, x to the 2n divided by 2n factorial. Alright, so we have the alternating series part, x to the 2n, and then 2n factorial. Now, for the Maclaurin series, since this is a cosine of 1/15 x squared, instead of cosine of x, we're going to replace all the x's with 1/15 x squared. And so this is the only x in here, 1/15, let's say 1/15 x squared. So that's what that turns out to be. Now it looks like what they did here is they left the 2n factorial in the denominator, but there's going to be a 15 here, 15 raised to the 2n power. The x squared raised to the 2n power will be x to the 4n, so that's taken care of. The alternating series portion of it, -1 to the n, is still there, so it's just going to be 15 raised to the 2n power. And I suppose we can simplify this. 15 squared is 225, so 225n, but let's just leave it at that and submit. Okay, that looks good so far. And now the Maclaurin series. Now this is just the cosine, and now we have to multiply everything by 13 times x. So the 13, I think, will just be there. So let's piece by piece try to put this together. We have the alternating series part. We have a fraction part. So what goes in the numerator? We have a constant 13. So let's leave that 13 there. And then we have an x to the 4n. So let's put the x to the 4n here. And then we're multiplying it by another x. So x times x to the 4n would just be x to the 4n plus 1. So that takes care of the 13x that's sitting out in front. Everything else should stay the same, and that would mean in the denominator we have a 15 raised to the 2n power, and then we have a 2n factorial. That's also there. Complicated looking function, complicated looking series, but really instead of rederiving the series, instead of doing the Taylor polynomials where we have to find the first, second, third derivatives, etc. Oh, I certainly don't want to find the third derivative of this function. Instead of doing that, we have a basis for a handful of functions like the cosine of x, and then we can just change its input, and then if you're multiplying by some other polynomial outside, you can do that easily as well. Alright, let's check this. Okay, looks good. Alright, good luck.